Welcome from Eisling to our today's webinar, Automation, Manufacturing Strategies and IoT. What are the key factors to really increase turn part productions? So we clearly picked out this topic for our today's webinar because I'm traveling around, all around the world, talking to many customers. And recently they always tell me or ask me the same questions. So what can we together with EMAG do in order to be also competitive in production locally here in Europe and also especially in Germany? So very often the key words automation, autonomy are raised up by our customers. And for all these questions, not for all, but for many of these questions, I guess the vertical pickup turning machine could be the right answer to be more efficient in the future and also to ensure to be successful in the future in production of turning parts in Europe as well as in Germany. My name is Björn Swatek. I'm Director Global Sales. I'm with EMAG since 8 years already. Before I was working 16 years for a different tool machine manufacturer. So in total, my business life is dealing since 24 years with tool machines. I'm not on my alone here in the room. So together with me, I would like to welcome Matthias Geiger. So Matthias, please also introduce yourself to the audience.
Yeah, so also from my side, warmly welcome to this webinar. My name is Matthias Geiger. I'm doing the product management for our standard machines. And I'm also over 20 years in the tool machine industry.
Thank you very much, Matthias. So before we start with our webinar, I would like to point out one organizational issue. So we try to keep it as vivid as possible. So it will not only be a PowerPoint presentation, you also have the possibility to enter this virtual room by asking questions. You have two different kind of possibilities. Possibility number one is you can just put your question inside the chat. Or if you don't want anybody to see your account, you can also use the question tab. So these are the two possibilities, and whenever you ask questions, we will try to answer them immediately during this webinar. Yeah, now I would like to hand over to Matthias. So I wish you, as the audience, interesting 60 minutes. So Matthias, please.
Okay, then let's start with the presentation. We split it into 4 sections. The first section are some general advantages from our pickup machines. Second is some sample use cases with flexible automation solutions. The third one are some quality features we have in our machines. And fourth are we giving you some insights to our production units. So based on the vertical machine concept, of course, the vertical machines have a very small footprint. And as a result of this, we have a good chip fall. The machine has always an integrated automation system and loads itself. And because of this automation system, it's very easy to interlink these single machines to an automation line. So why are still horizontal machines are needed in the market? So it's very easy because the vertical concept has some physical constraints in terms of part size and weight. In this slide, we shown you a comparison between the vertical pickup concept and horizontal machines. We picked 2 work parts with the same machining content, so the cycle time or the machining time is the same, so that it's comparable. And we find out very quickly that one of the main factors or the main difference between the 2 concepts is the integrated automation, which is usable or integrated in the vertical machine concepts, because this conveyor can be loaded independently to the cycle time. The conveyor can also be used as a part storage, and the operator can do measurement tasks without having the time pressure of the cycle time. So without this conveyor belt, it's much more difficult to keep the machine running without any downtime in the horizontal concept. So as a result of this comparison is that the output of vertical machines are in average 10 to 12% higher than in the horizontal way.
Matthias, may I interrupt you because first question is popping up. So am I not more flexible with horizontal machines? Both wheels and shafts can be machined. I don't have this option with the machine shown. Can you say anything in this regard?
That's right. In this webinar, we are talking about the pickup machines. So it's not really the focus on shaft machining, but I think the person who gave us the question has the need to have a wide product range between wheels and shafts. And maybe, I guess, they have only small batches, only a few parts have to be produced in one row, and then they have to change to another part type. And in case of this, maybe a horizontal machine is a more flexible solution than this. In the vertical way, or in the vertical world, we have the advantage that in this case we can put some parts on the conveyor and use this as stock. We have a high series production, and then it's more efficient to use the vertical concept.
Yeah, I fully agree. So I'm talking to many customers globally, and I think it depends on the focus of the customer. If they have the focus productivity, then maybe it very easily goes into the direction of the vertical turning pickup machine. So I always tell our customers, as soon as they have enough raw material, in the batch size is high enough that they can load our old conveyor band, then it goes into the direction of a vertical pickup machine from my point of view. If the focus is flexibility, if they have 3 parts today, 5 tomorrow, 10, 50 parts, batch sizes like this, and if they do not know today what will happen tomorrow, so like a job shopper, then maybe a horizontal turning machine is a good choice. Okay.
Then continue with some sample use cases in the with flexible automations. We start very simple with a single machine standing side by side. Because of the integrated automation system and the conveyor, it's easily operated by one man, can operate several machines. So that's the easiest example. The next one, we have some machines, different machine sizes, interlinked with, it's not really shown in this case, but interlinked with our own track motion system, but it also can be used with a gantry automation because all of our machines have in the back of the machine behind the working area an automation lane prepared to use it with the track motion, with the gantry, or with other conveyors or shuttles.
Yeah, maybe here I can jump in. So this is a diff case line from EMAG, which we sold several times all around the world, in Asia, in Europe, as well as in Americas. So you can see an application where we have 4 different kind of machines. So this is normally the case if we are talking about a diff case. So OP10 is turning off the first side, then we flip it around by 180 degrees, then it's turning off the second side. Then we have a VT4 machine. This is a shaft turning machine where we clamp the part between the centers, and we can do in one clamping the upper and the lower diameter. This is very important in order to reach the critical accuracies. And then in this case we have a closed diff case with a full sphere. So there we have the possibility to enter with a tool, with a banana tool, inside the workpiece through the window. So that's why we can flip it around by 90 degrees, and then with a basic machine, a general machine like a VL6 in this case, we can do the internal sphere machining. Just to give you a feeling, normally the takt time is around 100 seconds for each individual process, but also the line takt is around 100 seconds. This is normally also a little bit driven by the philosophy if the ring gear is laser welded to the diff case or if it's mounted by screws. If it's mounted by screws, we have to integrate in our turning process as well the boring application of the holes. Then it takes a little bit longer, but just to give you a feeling, normally 100 seconds is the takt time of the whole line. You do not only see modular machines from EMAG in this case, you also see our modular automation. We are very flexible with this automation system, so it consists out of different stacks. The tracks have a size of 300, 600 or 1200 millimeters, and then based on the individual needs of our customers, we can change easily the length of the track motion, and like you can see it in this case, we can also integrate peripheries like measuring or cleaning. So this, from my point of view, is a very good example to show you out of our modular box, a complete turnkey system consists out of machines, automation and peripheries.
So going to the next slide, this production line is has similar the same machining content than the slide before. We are also talking about 4 operations for differential housing, but this example shows you that it's no must to use our track motion system. You also can realize it with shuttles and interlinked machines or with a robot. The advantage in this case is that robots can be used for additional applications, for example, for measuring or cleaning the part, and for outfeed or other things you can do, brushing, for example.
Matthias, one more question. So when do you switch to robots, when to track motion? What are the advantages, disadvantages of the respective automation system?
So basically, it depends a little bit on the customer and their preferences, but normally you can say when you have 2 or 3 machines, maybe in a circle, and have additional tasks for a robot to do, I think the robot cell is maybe the more flexible solutions in this case. But if you have only the space for a line production in your plant, then maybe our track motion system or a gantry solution can be the better way.
Yeah, you're right. This is the technical point of view. If we also consider maybe the price point of view or the investment point of view, then I would like to remind you as an audience to the diff case line I just showed to you. So this is a good possibility where you can see everything coming from one hand, out of one supplier from EMAG. We can deliver to you a full package of machine automation and peripheries, and this, by the way, is also the most cost-effective or efficient solution we can offer.
So then let's switch to a duo concept of our standards machine. It's a VL3 Duo. Can be realized with a stacker on the left, on the right, or on both sides. I think it's a very smart and compact solution because the stacker, and you see also a short track motion in the back of the machine. Here you can see the automation lane behind the working areas. And the smart solution in this case is that the stacker and the track motion itself are fully controlled of the machine control, so you don't need an additional cabinet. It's no additional control necessary. So in total, it's a very compact and cost-saving solutions.
Matthias, again a question. I think this is more linked to the previous slides, so that's why we have to answer it now from my point of view. Can the machines be subsequently automated? How high is the cost? Is this economically justifiable? So I think it's dedicated to the track motion.
Yeah, so the technical answer is yes, of course. It can be interlinked step by step. The automation line behind the working areas is always prepared in the machine and covered with some metal sheets, so it's always available. So of course you have to change in the normal machines, VL2, VL4 for example, the normal O-type band to a shuttle, so you have to exchange a few things. But if it depends from the economical side, I think you have to calculate the savings at the end of the year to say if it makes sense or not. But technically it's possible.
Okay, I think this is the most important message. Technically, it's possible. Maybe if there are so many questions in regards to track motion, and you have shown so many nice applications with robot cells, maybe we also have to add that we also have gantry solutions. So maybe you can also tell our audience 2 or 3 sentences in this regards, because I think we didn't show it so far.
Yes, the automation lane in the backside of the machine, it's not fixed to use with a track motion or with shuttles, for example. This also can be used with a gantry solution, so it's a free space which can be used flexible. So that's the machine load and unload situation. And the second part of the question, I think it's the interlinking between some machines, maybe to combine it with a turnover application of this. So we have a few smaller gantry solutions where we can use, but it depends, of course, on the process, on the work part.
Okay, yeah, thank you.
So now we get one step higher in a just more complex arrangement. We can see here 2 wheel-free duos, not with a track motion. We realized that with with a double L shuttle to the left and to the right side of the machine, and place a robot in the middle. We have an additional application in the back of this robot cell, and the part flow is going to the front. Again, one step higher in the complexity grade. We see here also the wheel-free duo, 2 machines with double L shuttle, but we have now a part storage in the lower front, a part orientation next to them. The robot can feed all 4 rows of the 2 machines, so we have a 4 times OP10 machining in this example, and the second robot feed the measuring gauge and can, of course, outfeed the not okay parts, and the finished parts will be outfeed in 4 rows separate to each spindle. So now we had a few slides with duo concepts, with dual machines, but it's also possible with all our single machines with wheel 4, 6, 8 to use a shuttle to the left or to the right and create a robot cell with additional tasks. And in this case also the part flow was not with conveyors, it was with boxes, but also to the front. In this slide there's shown that it's no must that the robot always have to be placed in the middle of 2 machines. We have here 2 VL6 machines standing side by side with a L shuttle, and the right machine has a long L shuttle through the automation lane of the machine standing next to it. We have the robot cell also with additional tasks with, in this case, laser marking, post-process measuring, and of course also SPC if necessary. So now we're jumping to the next chapter of our webinar and talk about some quality features we have in our machines. All of our machine columns are made of polymer concrete called mineralite, which have a much better damping behavior than a grey cast iron. We are always using water-cooled motor spindles to get a good temperature behavior and have a much better acceleration to the rounds per minute you need for the process. We have we're using in all axis linear scales. We have an integrated measuring probe outside the working area. I think that's an important thing. It's not in one tool position and in the dirty working area. It's between the conveyor and the turret. We have of course solidly dimensioned guide sizes and bearing diameters. We always use roller guides in all axes. The roller guides had the advantage that we have a line contact and no point contact of ball guides, and this results in a much higher workload possible. So it's a robust, a stable machine concept in this case, and we have our own high performance revolver. High performance turret to realize more ambitious milling tasks. So for those who are not so familiar with the VL2, for example, we have a short animation how this machine is built. We see the base frame in the column in a vertical way. We have the cross slide at the top of the machine, some guiding metal sheets, to secure a good chip fall. Of course, some covers to close the working area, the turret on the right side of the column. In this case, not with Y-axis and driven tool, but of course it's available as option. Here the mentioned measuring probe outside the working area, the integrated O-type conveyors, and at the back side of the machine, the electrical cabinet and the chip conveyor.
Yeah, I think if I also see this animation, yeah, we have to point out again that the integrated automation is the key of the vertical turning machine. So the spindle is not only responsible for turning the part, it's also responsible for loading and unloading. We have a small buffer with our O conveyor in standard, and this gives our customers from machine number one an autonomy. And yeah, then also it's much easier to take care about several machines, and the downtimes of the spindles are reduced dramatically compared to horizontals. So I think this is important again to mention.
Yeah. Now we have switched to the dual machine again. I think the most important are the other things I mentioned before already. We have a very compact design and the stacker up to 400 parts. But the most important message in this way that we have a high focus on that two different working areas are vibration isolated, and we had a lot of effort, we have done a lot of effort to realize it. So this slide makes you curious, hopefully, for the last chapter. We are not at the last chapter. The last chapter is going to have some insights of our production units. This slide only want to show that all of our components of the mineral casting beds, our columns, for example, the spindles, the turret, the cross-sliced, also our own self-made interlinking system with the drag motion. We have self-designed, self-built, self-produced, self-tested. So we have a lot of value depth in these cases in our company. So we have a second animation of the VL3 Duo to show you a little bit the sequence of the left and right working area. We have in this case a OP10 and OP20 part flow or sequence. So we see that the two responsible tasks for the main spindles to pick up the part and machine, machine of course. Put a half-finished part back to the shuttle system, and measuring between, for the post-process measuring, take the next raw part. The shuttle brings the part to the back side of the machine, drag motion, standing, prepared with the new raw part, turn over to OP20, bring the finished part back to the stacker, and take the next raw part. And of course, the sequence on the right side with OP20 is similar or equal to the OP10. So machine picks it up, machine it, and place it back on the shuttle.
Before we start with the track motion, one more spindle dedicated to the one more question dedicated to the VL3 Duo machine. How is it ensured in a double spindle design that the vibrations of one spindle are not transferred to the other one? Aren't there always problems with hard steels? The spindles sit on the same bed.
The spindles are on the same bed. That's correct. I cannot going to explain it in a deeply way. So because it's a little bit a company secret, but we secure that the two working areas are vibration isolated. So we took a lot of effort, and have you seen in the slide before, we always do the machine beds with a finite elemente method. So we calculate it very carefully and test it. So we can secure that there's no vibration coming from the right side to the left or vice versa.
Yeah, maybe two things I would like to add. So first of all, Let me jump back to the slide. So if we consider this slide, if we have a look to the massive machine basement, just one additional information. So the weight of this machine basement of the VL3 Duo is around 10 ton. And normally, as you know, a high mass is always a good idea if you want to absorb vibrations. And I will let you know, this is a second advantage. I will let you know later in my presentation the big benefits and the great benefits of using polymer concrete called Mineralit. So these two aspects from my point of view are also part of the secret if you don't want to tell the others.
So jump forward again to the track motion system. I don't want to go in detail to the technical data on the right table. I just want to note that we have, according to our different machine sizes, we have also two different track motion sizes. So that fits always to the machine size, of course. And so we are flexible in this way. There's a small film, be the guest of the gripper and drive with him to see the sequence again, what you have seen in the animation before. So the raw part is coming, putting down. We are also in a VL3 Duo at the moment in the backside. So there's a half finished part, turn over, bring it to the OP20, taking the finished part and goes back to the stacker.
Okay, Matthias, again, one question regarding the VL3 Duo. So you generated a lot of attention for this machine, but this is also the top seller, by the way, of the EMAG group. So when setting up the twin spindle machine, is the whole machine always stationary, or can the individual spindles be set up separately?
So when at one side of the machine there's a machining ongoing, you have sure access to the other working area. So a simple tool change can be done easily. Mm-hmm. So that's possible, yes.
Okay, I think this is the most important message for our customers. So tool changes, for example, to change the inserts, which is the most common case, is possible without. So you can do it on the right side, and the left side can still produce good parts. And this is, I think, interesting to know for our audience.
So we are coming to the next topic of our quality features. It's I think an important topic. It's sometimes invisible and, in my point of view, sometimes underrated. It's our IoT ready package, which is always included in our standard machines. This means that we installed in each machine axis sensors which collects the data of the SPS control and forward it to the separate IPC which is assembled in the control cabinet. And these raw data are prepared in this IPC for further analysis. Just to get a small overview which functions can be done with this raw data, we first of all we have a health check to plan and organize the predictive maintenance much better than in a normal way. We can visualize some product performances and bring it more transparent to the operator's panel in a form of dashboards. For example, we have several cloud solutions, internal the customer's network or external the customer's network. We support the optimization and the detailed planning. We need or create infrastructure for the data science pipeline of all these informations and raw data. And all these points are based on the machine data, but we also have a workpiece data recorder which support the traceability aspect. We collect all workpiece related machining parameters and data and can provide this as a data package. I just want to highlight one of this and goes a little bit more in detail, because if I do it for all these aspects, we have a separate webinar, and we only want to have a closer look on the health check itself.
Matthias, before you start with the health check, you were showing a few minutes ago the slide of the components of our IoT Ready package. There's one question in this regards: why an additional personal computer? Can't the control system be used for evaluation? I guess data evaluation.
Yeah, that's not possible in this case. The machine control itself only can provide the raw data from the SPS controls, but to prepare it for further analysis and to share it with cloud system and something like that, the machine control is not suitable for that. So that's make the needs more clearly why we need an additional IPC.
Maybe one thing I'm currently thinking about is, just for the audience, when we look again to our VL3 Duo, we have a 4-channel CNC control with the machine, and with this we can, or one channel is for spindle number 1, second channel is for spindle number 2, channel number 3 is for the translift of the track motion, and channel number 4 is for the raw and finished part conveyor. So if you say we cannot use the control also for the analyzers, I just want to mention that we already have a very complex system, and with one control with one pedal, you can run the whole machine, both working areas, also raw part, finished part, and also the automation system, which is, from my point of view, a big plus. You do not need a second control for just managing the automation, so everything can be done with the VL3 Duo in standard with our machine control. This is, I think, also a big plus. But again, now let's jump back to the health check.
Okay, we have before each machine has its own characteristics in a kind of fingerprint. Let's call it fingerprint. And because of this, we collect these reference data before we deliver the machine to the customer. And this data are, as I said before, the reference for our health check, which is done in defined time steps. So in the chart in the middle, you can see the 3 sensors which this example machine has, so the X and Z axis and the spindle. And if you only focus on the X axis, you see on the left chart the vibration sensor, the raw data of the vibration sensor of the X-axis divided in the 3 room spaces in X, Y, and Z. And you see on the amplitude that's not a behavior that we want to see, because here seems to be that one component of the X-axis is broken, or just right before that the machine has a downtime. So that's the best sign that you should order the spare part, for example, and plan the maintenance and to replace this broken unit to the new one. And you see on the right chart, that's the new reference. The sensors bring clear signals, and the machine health check is going back to normal.
Okay. Yeah, Matthias, before you hand over to me, to my point of the presentation or part of the presentation, one last question in this regards: IT security. So it's going into this direction. IT security is our top priority. How secure is my machine data against hacker or cyber attacks?
IT security is, of course, an important thing, and we realize it in several levels. We have the security on the machine. For example, we use a hardware router with an integrated firewall, so the machine is secured by attacks from outside with this firewall. When we realize cloud solutions in the internal network of the customer, then of course we have no connection to the outside, and the customer's network has the safety tasks. But if we provide or realize a cloud solution outside of this network, we realize it with Azure from Microsoft. So Microsoft has the safety task in this topic. But one additional note which is important to know is that we only get the signals from the customer's network. We don't write something back, so it's only a one-way track of signals. So there's no open point needed in the customer's network. We only bring the informations to the cloud solution.
Yeah, and at the end, of course, the customer can decide which data will be provided, for example, to EMAG, and which will remain inside the company.
Yeah.
Okay, thank you very much, Matthias, for for the first 35 minutes of this webinar. So let me summarize most of the added value which you mentioned in my words. So I noted down, first big plus of a vertical pickup machine is the integrated automation. I think we mentioned it already several times. So you have from machine one an autonomy, and you can also reduce the downtimes of the spindle, and this brings you from machine one an additional order OEE of 10 to 15%. Secondly, I noted down we are using high quality, modern state-of-the-art components like roller bearings, so we always have line contact, which compared to a point contact, which is extremely important if we are looking for a long-term machine life. So then you also have an accuracy, also if the machine is 10 or even 20 or 25 years old. So I saw a lot of EMAG machines in the field at our customers, 25 years old, still producing good parts. So this is one part of the secret. Second or third point is, we as EMAG can deliver everything out of one company, machine, automation, peripheries. So if it is requested and needed, we can be the only contact person for our customers, also if we are talking about very complex turnkey solutions. And last but not least, we can offer everything from a standalone machine up to a full turnkey system, turnkey solution system. So this is a very wide range which we offer, and we offer always this what is requested from our customers, and we always try to find the best solution dedicated to the real customer needs. I just received an additional question. It's regarding Siemens. Is this a Siemens control solution line? Siemens 1, so yeah, we are using Siemens 840D solution line. Siemens 1 is step-by-step implemented, but I think you are the right person also to give some information in this regards.
Yes, so the actual status is that we are using final control for the standard machines and also Siemens, but for the Siemens we have at the moment solution line in progress. We have a continuously release management running in the background, so we're always preparing in half-year steps additional options and more features. And of course we are planning to change to integrate Siemens 1 in our standard machines, but I think it needs a little bit more time about this. So the actual status is that we're using the solution line.
Okay, and yeah, you're right. We're using funnel control as well. This is normally in standard. Just an additional information, we are using the 32i, for example, for the VL3 Duo, and for simpler machines where we do not have so many axes like the VL machines, we are using the 16i, funnel 16i control. So then let's jump back to my presentation. I would like to give you inside views of our production. So EMAG 1992 launched the vertical pickup machine to the market as a first tool machine manufacturer. Since 1992, we permanently improved our machine designs, our machine concepts, but also our automation processes. And last but not least, we still or we also consider to optimize our production on a regular basis. From my point of view, there is also a lot of experience inside our production. So we have two production, one in Asia, one in Europe, and all or both production units are fulfilling the same requirements. They are using the same philosophy, and yeah, in regards to other machine tool manufacturers, I would like to point out two points which are, from my point of view, extraordinary and important also for you to know. So we have a very high depth of production. So we are doing from the foundry, so from the column, which is the basement of the VL machine, for example, to the last screw on the cabinet of our machines. We are doing everything locally in our facilities, so we do not have many suppliers. So we are doing our turrets on our own. We are doing the spindles on our own, and yeah, this is from my point of view for us very important to be very fast and also to react on the individual and special customer needs you hand over to us. And the second point is we are always following the lean production philosophy, which means that we always try to avoid waste in regards to material, waste in regards to inefficient walking through the factory. And this is also one example how we can reduce the time the machine needs for assembly, but also at the end this is money, and this is also what you can benefit from. So the first 5 years when I started at EMAG, I was responsible for the modular solutions for the VL machines, the VL3 Duo, for example, as well. So that's why I know these processes quite good, and I would like to explain some of these, focusing on 4 points. Point number one is the mineralite polymer concrete foundry. Point number 2 is the component production, the mechanical machining. Point number 3 is the spindle manufacturing. And last but not least, point number 4, I would like to explain to you is the flow line concept we follow. And I would like to give you some insights as well here. So let's start with point number 1. So we are, as mentioned by Matthias, only using polymer concrete mineralite machine beds. So we are not using cast iron machine beds or even steel welded constructions. So we decided from 1992 beginning that we will focus and that we will rely on the polymer concrete mineralite philosophy. So here you see 3 pictures so that it's easier for you to understand the philosophy and the idea of the polymer concrete production. So if you're not familiar with this, with it, on picture number 1, you see a mold, which is where you can also see some surface resin. So this should be the basement, or that should enable our polymer concrete to go easily inside the mold in every corner and to make a very good flow concept at the end. You can also see that we prepared to put in the surfaces and the components where at the end the linear guideways, for example, will be mounted. So all these surfaces we have to add in our mold. Then we see our second picture where you can see the automated foundry or casting process. It's a cold casting process, and it's the polymer concrete is filled into the mold. Parallel, there is the mold is on a vibration plate, so that it's really getting a very high density, and that we have a very smooth outcome at the end of the polymer concrete. And then on this third picture, you can see the last step. So normally it takes around 24 hours to harden the column. So we have to leave the column after the casting process for 24 hours in our production, and afterwards it can be machined. So just to give you a feeling how it looks like, a video where you can see the automated polymer concrete casting process inside a mold of a column. And this is the same process which we implemented in all of our production facilities which we have globally. 2 points, or 2 additional points I would like to point out additionally. So first of all, if you are hearing maybe a casting process, maybe you think this is not an accurate process, but it's the other way around. It's a high accurate, high precision casting process. So after machining on our milling machine, we can ensure a tolerance range of 10 micron only If we consider, for example, a column of a height of 2 meters, so 10 microns only on the whole length of the 2 meter column. First of all, it's a high precision casting process, but on the top right position of this slide, you can also see our vertical milling machine. So we also have the experience, or made the experience, that it's very important that you machine the column in the same orientation as you assemble it later on in the machine. So if you do it maybe differently, you do the machining process horizontal and then you assemble it vertical, normally then it generates some problems and you will not reach the 10 micron of a length of 2 meters. And last but not least, this is the most important point, we are using mineralite polymer concrete because it has 10 times more or higher abilities in order to absorb vibrations. And also the vibration amplitude from beginning is smaller in mineralite polymer concrete beds compared to cast iron beds, and it will be faster absorbed. And if we are talking about this, where's the customer added value? So less vibration in the whole machine concept means also less vibration at the end, as at the cutting edge of our tools or your tools. And if we are talking about a long-term machine tool life of 10 or 20 years, then at the end this is very important for you that we also keep the tool life as long as possible in order to reduce the money for tools. And last but not least, which is also important to mention, is that also we can limit or decrease the noise by using mineralite concrete beds because of less vibration. And at the end, this is also important if you have many machines in your shop floor. So let's jump to the second additional point I would like to mention. You will see later on a video of our shop floor, and in this video you will see a lot of different kind of machines. That's why some of them I would like to mention. There's 5-axis simultaneous milling machines from Hövel, for example, Burkhardt & Weber WFL turning machines. We are also using our mill turn machines or our turning machines from in-house, from EMAG, to generate quality. And what Matthias already mentioned, we still have the whole process chain, the whole production depth in our factory. So we are doing the e-containers assembly in-house. So whenever there are some special needs of our customers, we can dedicate on this and realize them directly with changes inside the factory because we have the process in our hands still. We are doing the automation system, the track motion, locally in our production facilities. And last but not least, we are also having a shuttle meat production where we are doing bending, laser cutting, and at the end also powder coating. We have a powder coating system in our shop floor, so we can also do all internal metal sheets as well as the whole cabinet of the machine tool in-house. You also see the schematic view of the cutting view of the turret. So we are also doing them locally in our facilities. They are water cooled in standard. They have a torque motor for rotating of the disc in standard. And also if needed, if you need a direct driven live tool, we can also offer this as an option. So whatever is needed. So we are very quick with changes. If we wanna change anything dedicated to special customer needs, we still have everything in our hands. We have the construction department in our facilities. We can change drawings and afterwards also the production process quickly. So this is very important in order to be able to offer high sophisticated turnkey solutions. Before I move on, another question. What about the spare parts supply? Do all spare parts come from the two plants? What are the delivery times? So maybe I start. So in total, EMAG has around 2,700 employees. Around 400 of these employers are working in the file service. So this is one of our main focus. We know we are not only delivering standalone machines. If we deliver high sophisticated full turnkey systems, then it's very important that we avoid downtimes. And if there are downtimes, we have to be very quick and very close to our customers. So 400 people in the field is important, that we are very quick at our machines, at our customers in Asia, in Europe, as well as in Americas. And second information, we are currently doing the webinar in Eislingen, and in Eislingen we have our headquarter for spare parts. So here is the global spare parts hub. I think we have around 20 million euro spare parts in value stored here, and we always ensure that every part is as quick as possible wherever it is needed globally. Of course, we also have smaller spare part hubs in Asia as well as in Americas, but these spare parts hubs are dedicated to the installed bases, and they cover the most needed spare parts of the installed bases in the relevant market. And here in Eislingen, as I mentioned, we have around 20 million euro spare parts value stored for the whole installed bases globally. I hope this answered the question. Then I show you another video to finalize my presentation regarding the turrets. So this is not rocket science, which I want to show to you, but I only want to mention this is a system which we generated also by ourselves in order to measure the position of each individual station of a turret disc. And this is important, so you know it's very important that, for example, the center of the main spindle is in line with the center of the tool station. If you are, for example, doing long borings, and if you have long bores or boring tools on the turret, then it's very important that everything is 100% accurate. And I don't want to show you, as I mentioned, rocket science by showing the system. It's more to give you a feeling that we still have quality, relevant processes inside EMAG and still in our hand. Last but not least, this is a view into our measuring room. By the way, the whole production is temperature controlled, but of course the measuring room as well. You see a lot of size measuring machines, 5-axis measuring machines, for example, and we have a 100% measuring of our cast iron parts implemented in our processes. So this is dedicated to slides, which you see on the picture, but also on the columns, which have been shown before when I was introducing the foundry. Also our VL columns, as well as the VL3 Duo column with a weight of 10 tons, is put on the size machines, and then we measure also for example, the tolerance of the milled contact surfaces for the linear guideways. So this is finally a video of our shop floor production. You see 5-axis simultaneous milling machines. You see a lot of grinding machines from EMAG. You see mill turn machines from EMAG. Some machines with tool magazine, and also some milling machines with a different kind of milling machines for doing the bigger parts. And this is, let's say, one of our reasons how we can generate and create quality. Let's come to the second point. This is or the third point. This is the manufacturing of the spindle. So normally in our business, this is not only the philosophy of EMAG. I think it's the philosophy of most or all of the tool machine manufacturers, or even also of the users of tool machines. A lot of people say that the main spindle of a tool machine, of a turning machine, is the heart of the machine. We have the same understanding, and that's why we decided not to purchase spindles from suppliers, but to keep the philosophy also alive, to build them on our own in all of our factories. So yeah, as you know, the rotor shaft is one of the most critical parts. There's a very detailed, very extensive and also expensive turning process in advance. Then it needs to be grinded, and yeah, this is very important, and that's why we also keep it inside the EMAG production.
Or maybe just a side note to the spindles, because of the fact that we have the design and the experience in our own hand, we can design it, or we realize it in the design kits. So we try to keep the proven design principles and only change some few things, for the motor, for example, to realize different power levels. So we keep it modular.
Yeah, this is definitely also a big advantage. If you do it on your own, you also can have the design process as well under control, and also the design changes. This is just to give you a feeling how it looks like rotor shaft grinding. So as I mentioned, it's very important, a very critical part, and that's why it is decided that we still do it in our production on our own. Last but not least, I would like to draw your attention to the flow line production principle of EMAG. So in general, we subdivide the way of doing assembly in tool machine business into two different kind of philosophies. One is the box assembly, where a project will be dedicated to one individual place or one individual box. And from the beginning of the assembly to the end, to the final assembly, the machine will remain at one individual position. So in comparison to that, we follow the flow line assembly at our factory, where we are producing the modular solution machines, the VL and VL Duo machines. So we subdivided the assembly process into 18 tacts. And in every tact, if you do it like this, you have the big advantage that dedicated to each individual tact, you can consider the material which is needed in the individual tact close to the machine, the right people who have abilities for this specific needed work, and you can also place the needed information at the relevant tact. So this is a big advantage. We always say that at the flow line assembly principle, machines are moving, people and material is immobile at the machine, so not moving. And if we consider the box assembly, then normally we say that the machines are standing still, not moving, and people and material needs to move. And as I mentioned, we have the clear philosophy to decrease and avoid waste. So just to summarize, we, for example, in the production where we produce the modular standard machines, we have two lines. One is for the more commodity machines, the VL series, VL2, 4, 6, and 8. So there we have 18 cycles, and every cycle, if we move the machines from cycle number 1 to cycle number 2, it takes around 4 hours. So per shift, we can produce 2 machines. And then we have a second line, a second assembly line, where we, in a mix, can produce VT2, VT4, the shaft turning machines, as well as the VL3 dual machines. And there the cycle is a little longer due to the higher complexity of the machine. It's 8 hours. So this is how it works at EMAG. And finally, I would like to give you a last view in our production, where you can see our philosophy, same shop floor philosophy in our factories, also in our production and in our shop floor in Heubach, for example, in Germany, in Saarland in Germany, or in EMAG LSC in Farmington Hills, close to Detroit. So the standards and the shop floor philosophy, for example, we implemented everywhere globally around the world. Yeah, so now we come to the end of our webinar. So I would like to thank first of all Matthias. Thanks that we could both do this webinar together. So it was a pleasure for me to do it with you. And last but not least, thank you very much for you as an audience. Thanks for listening. Thanks for paying attention to our topic. And I hope you get some impulses so that you or in this case, I would like to welcome you also after the webinar to get in contact with us, to go deeper into a discussion so that we can take care about your individual needs as well, also after the webinar. So you can still write questions and we will answer all of them after the webinar via email, or we will get in contact with you via telephone. So thank you very much. Enjoy the rest of the week, and yeah, thanks for listening.